Okay, looks like it's down to a trickle, so let's go ahead and get started. Thank you all for joining us today. Welcome to today's CNCF webinar, Kubernetes in Production, Operating etcd with etcdadm. My name is Ariel Jatib. I'm a CNCF ambassador and a TME here at NetApp, and I'll be moderating today's webinar. We'd like to welcome our presenter today, Daniel Lipovetsky from Platform 9. I got it right again?
You got it right, Ariel. Thanks.
All right. Before we get started, a couple of housekeeping items. During the webinar, you're not able to talk, so as an attendee, if you have any questions, there's a Q&A box right down at the bottom of your screen. Please feel free to drop your questions in there, and we'll get to as many as we can at the end of the talk and the demo. So without further ado, oh, one more thing, this thing is being recorded, and we'll send out the recording link afterwards, also with the presentation. And now with that, I'll hand it off to Daniel to tell us all about etcd and etcdadm.
Great, thank you very much for the introduction, Ariel. Yeah, like Ariel said, my name is Daniel Lipovetsky. I'm a software engineer. I've been working on Kubernetes cluster lifecycle tooling for about 3 years at Platform 9. Platform 9 helps our customers deploy and manage Kubernetes clusters on premises and in different public clouds. And today I want to talk about the etcdadm tool and its sort of its beginnings, it's the reason why it exists, the motivations, and those are you know, the lessons that we've learned in production. So to begin, etcdadm. It's a CLI, and it's meant to simplify etcd operation, including disaster recovery. Inspired by lessons learned running Kubernetes in production, and importantly, it's an open source community project. You can find it on GitHub. It's adopted by the Kubernetes Cluster Lifecycle Special Interest Group. And it's easy to install. It's a single Go binary. You can go get it. And we'll have binary releases coming soon. So why does etcdadm exist? I want to talk about some of the lessons that we've learned in production. And before I go into those, I just want to set one definition, which is the control plane. So when I'm talking about the control plane, or when you think about the Kubernetes control plane, think of a group of stateless components, which is the API server, which is, of course, you know, accepting all the requests and responding to them. And then the controller manager where the different controllers are running for example, for your replica sets or your deployments, or even for nodes. And then, of course, the scheduler, which is responsible for assigning nodes to pods. And finally, there is one stateful component, and that is etcd. That's a distributed database, and it holds all of the state of the Kubernetes cluster, everything that's stored in the Kubernetes API. So lesson number one is that API uptime is critical. Without the API, the cluster is a zombie. I neglected to insert a zombie meme here, but what I mean by zombie is that the workloads that you have running continue to run, but anything that needs API access really can't make progress. And you know, in the early days of Kubernetes, that was the core, you know, the core components. You can think of kubeproxy, which was responsible for routing pod to service to pod communication. But now the API, the Kubernetes API, has become even more critical as important add-ons like service meshes and API gateways and even functions as a service implementations are using CRDs, and they're using the Kubernetes API to store and to interact with users and to store all of their data. So that's lesson one. Lesson two is that many API outages are due to etcd failure. When you have an API outage, it's not always easy to determine the cause, but as a first step, you could check the component statuses. That's a kubectl get component statuses command. If the API server is responding at all, sometimes it begins the crash loop, at which point that's not even useful. Sometimes you just have to go to the API server log. One way of finding whether there's something amiss with etcd is to grep for etcd server or etcd in the log. And another lesson that we've learned the hard way is that complete etcd failure does happen. So regardless of whether you're running 3-member clusters or 5-member clusters, you will at some point experience a complete outage, and that outage may there may be no way to recover those members, and so it's important to be able to recover the cluster from a backup, for example, and that may happen at any point of the day or night. And we've also learned that it's important to have a manual etcd recovery process, and I'll talk about that later on. And finally, periodic etcd backups are important, but try to recover the latest state if possible. Okay, so from those lessons learned in production, we know we want to address or make sure of a couple of things, right? We want to make sure that the API is up as much as possible. And there are two strategies to doing this. One is to ensure that you can tolerate partial failure of the control plane, and that you can reduce the recovery time from either a partial failure or a complete failure. There are two strategies, and you need both of them. So how do we tolerate partial failure? Well, we can deploy multiple control plane replicas. This is slightly easier because they're stateless, and if you have some configuration set, you can just create all the replicas you want. You'll need to route your requests to the various API servers. If you may have a load balancer, and you'll need to update the load balancer records to point to your new replicas, or you may have you may be doing failover, in which case you may be running something like keep alive D. But in any case, it's stateless. You can deploy the replicas in parallel. It's relatively easy to do, and there's not a performance penalty. The API server also is designed to be able to run with multiple copies. It will be able to resolve resolve conflicts when there are conflicts, or reject requests that are maybe conflicting with a concurrent request. And then the other components like the scheduler and the node or the controller manager are designed to elect a leader if there are multiple replicas running and avoid conflict that way. So that's one part. The other part is that you need to deploy multiple etcd members. If you have multiple control plane replicas, but just a single etcd member, if that etcd member fails, then the API server is unable to, any of those replicas are unable to serve requests anymore. So deploying multiple etcd members is harder. It's a stateful component, and not only that, but there is a performance penalty for doing that. So as the number of members increases, what's called the majority of the etcd cluster, the majority of the members need to process reads and writes, and so those are of course going over the network. So as you go from one member, which is handling everything locally, to multiple members where traffic is going over the network, the performance does decrease. So that's how we would deal with partial or handling partial failure. The other strategy that we need is how to reduce recovery time, right? So we have a couple options, right? We could write a service to automate recovery. Now, this tends to be more complex and less flexible, right? And there are some corner cases, you know, in a failure that you may just not predict. And typically, if you write a service to automatically recover, you know, distributed database, that's going to depend on external APIs, whether it's to, you know, bring up new instances where you're going to be running etcd, or even to figure out, you know, whether some instances are, you know, partitioned on the network, or, you know, if there's been, you know, a hard disk crash, or, you know, an instance has been deleted maybe by a user. And of course, it's harder to debug and to patch. You know, if you find that there is an issue at the very time that you need to recover, you know, you just don't have very much time to sort of investigate, you know, what this automatic recovery service is, if it's doing something incorrectly. And finally, yeah, you're trying to ensure that, you know, that you're tolerating partial failure and being able to recover this one distributed system, which is etcd. But then it turns out, if you want to have this automated recovery service, you sort of have to solve that problem for the service. On the other hand, you can implement a manual recovery process, and that process can be made simple with tooling. Importantly, it has no dependencies, and it's easier to debug and to patch if there is, you know, if there's a corner case that you didn't anticipate that you need to handle during this, you know, critical recovery phase. So etcdadm was designed with those ideas in mind, right? So its goals are to make it easy to tolerate partial etcd failure, to make it easy to have a manual etcd recovery process, and to work without dependencies on external services like DNS or network storage. And of course, etcdadm wants to compose well with other tools. So, you know, for example, you can use kubeadm, which was a huge inspiration for etcdadm, in order to deploy control plane replicas. And okay, enough exposition. Let's demo. I want to show how we can use etcdadm to deploy a multi-member cluster, and then how we can scale that cluster, and finally how to recover from failure. Okay, how to deploy a multi-member cluster. So again, a couple of options. One, we can deploy all members atomically. In order to do this, you have to use what's called the etcd discovery service, or DNS and update DNS records, or use what's called a static deployment, where you configure all of the members initially and then start them up in parallel. So the other option is to deploy one member at a time and then scale up. So etcdadm chooses to do the latter, and the reason is that, or there are a few reasons, right? One is that there's just one mechanism to understand, the scaling mechanism. There's no dependency on DNS or an external discovery service, and it's easier to understand when something goes wrong. The drawback is that you deploy members sequentially, so you're not deploying them in parallel and letting them sort of converge. But it's pretty straightforward. So let's go ahead and do that. Let's create the first member. So I've got sessions open on about three hosts, and I will initialize the first etcd member. So this is, I'm just running etcd here, and now we've got an etcd service running, and I'll just query the etcd API. So let me give you a quick rundown of what's happening behind the scenes. So when I run etcdadm init, it will generate the CA certificate, and then use that to generate, to sign server and client certificates. The CA certificate or all of these certificates rather, are what's used to establish trust among the different etcd members. And then also client certificates are of course used by, for example, the Kubernetes API server to be able to talk to etcd. So etcdadm will generate those. It'll write configuration, and then it'll create and start the systemd service. So yeah, I've got a single member etcd cluster up and running with just a single command. Now, the next thing that I want to do is scale up my cluster. So in order to do that, I'll want to copy over the CA cert and key. And that is so the other members can use that to sign their server and client certificates. And as long as the same CA is used to sign the certs, then the members will trust one another's certificates because they trust that CA. So let me go ahead and do that. Let me copy over the certificates. Oops. There we go. Okay, so I'll copy it over to one host, and I'll copy it over to another host. And let me go over. So now I'm on the second host, and now actually I've forgotten what I need to type, but I can go back, and if I look at the output of etcdadm, it will actually give me a helpful hint. This is also inspired by kubeadm. So I can copy and paste this command and run that on the second host. And as long as I have the certs there, let me just demonstrate that the certs are there. I've just copied those over. So now as the certs are there, I should be able to scale the cluster up. Okay, so what's happened here behind the scenes is a little bit more complicated. First of all, etcdadm saw that there was an existing CA cert, so it used that to sign the server and client certificates. And then etcdadm actually called up to the existing etcd cluster and added this new host using the members API. And after it did that successfully, then it brought up, wrote the configuration and started the etcd service. And again, let's just check out the members in this cluster now. And I'd like to point out that I'm using etcdcuddle.sh. If you've used etcd before, you may be familiar with the etcdcuddle tool. It's a great CLI tool, but one of its drawbacks is that if you're using it with a cluster that has TLS enabled, you'll need to pass in either command line flags or set some environment variables so that etcdcuddle knows about those certificates and where to read them from the disk. And if you're using it with the v3 API, as we are, you'll also need to set another environment variable or command line flag. And so etcdcuddle.sh is just a tiny shell script that we bundle with etcdadm that sets those environment variables and then calls etcdcuddle for you. So yeah, just a little bit of convenience when you're using that interactively. So okay, so now we've got this two-member cluster, and let's go and scale up to 3. So again, I just want to show that we've got the certs there, and I can use that same command to join. I can also switch the endpoint to a different endpoint. Any one in the cluster is fine. So we just added this 10.105.16.195. So I'll use that to join. As long as it's an endpoint that's responding and etcdadm can call the API, we're good to go. Okay, so now we've got that 3 member cluster. Okay. At some point, you may want to scale down. And to do that, it's a symmetric interface. You run etcdadm reset on that member to have it leave the cluster gracefully. I'll demo that in a little bit when we talk about handling failures. So now that we've got our 3-member cluster, okay, we want to, so now we're at the point where we're able to tolerate partial failure. So I could demonstrate that, for example, if I stop the etcd service, and actually let me demonstrate. So endpoint health. So this is I'm making requests to all of the different members, and all of them are able to respond. So except a read and a write. And now let me take one offline by stopping the service on one of the hosts. And now here this will fail because I'm making a connection to the local etcd member. But let me do that from a different host, and then we can see that the 2 members are responding. One is not. That's the one where the systemd service is stopped. But importantly, I'm able to both read and write to the database. So let me go and let me start that back up. So that was an example of partial failure, right? We had one member that was unavailable, but the cluster was still able to accept reads and writes. And now that member is back, and we have all 3 members running again. So we can now handle partial failure, right? Just by deploying multiple members. Now, I want to, before I go into the next section, set a couple definitions. So a minority failure is a partial failure where a majority of members are still available. As I mentioned before, in order for the etcd to accept any read or write, a majority of the members must be available. So an example of a minority failure could be something like planned maintenance, right? I have to, update the kernel on some member and restart the operating system, and it will be down for the duration of that restart. It could be a network partition, or it might even be, a hard disk failure on a minority of the members. On the other hand, there's a majority failure, and this is a partial or complete failure where a majority of members are not available. So what I mean by complete failure is that when you've lost everything. So if you're running an etcd cluster in a single data center, and that data center goes offline, you've lost the cluster, and maybe you've lost network storage. So we've seen where we have multiple members, but they are all backed by by the same network storage, and at some point, for different reasons, right? You could have corruption, or you could have disk failure, and one or more members can be affected by that, and sometimes all of them. So I want to briefly talk about how to prepare for a planned minority failure. So a planned minority failure, right, is like planned maintenance. First, I want to consider how many failures your cluster can tolerate. So if you have 3 members, you can tolerate at most 1 failure while still able to accept reads and writes. Okay, so if we want to, patch the kernel on one of these hosts, we can do that. We know that the etcd will continue to be up, and thus our very important control plane and API will continue to run. So we have options of how to prepare. One is we can just do nothing. What I mean by do nothing is that we just patch the kernel and restart, and once that restart happens, the service will run again. It'll read the data from disk, it'll catch up, and if everything goes well, it'll just be a temporary, just like when I stopped that etcd service. That's a little bit risky because you can't always predict what effect your maintenance will have. And the other option that you have is to migrate the member. So you can actually take the data on disk, copy it to a different machine, and then make some changes to the metadata of that member, because the rest of your cluster is up and that API is available. And then we basically start running that same member with a different network ID, with a different IP. It's a special procedure to do that, but the advantage is that there's less data to catch up on after migrating, because there's the bulk of the data is already on disk. You've just copied it over. And the third option is to just replace the member. So this is nice because it reuses the scaling procedure. First, you scale up, right? So you add. So if I have 3 members, I'm going to add a fourth, and then I will remove the member that I want to perform maintenance on. The downside is that there is more data to catch up on for that member that's being added. So you'll need to wait some time for that new member to catch up to the cluster. So let's take a look at what we can, or how we can do this with etcdadm, which makes that third option easy, which is to replace the member. And again, this is so that there's not a special procedure to use. You can just use the same scale up and scale down procedure. So let me actually take this node that we have, and let me run etcdadm reset on it, and this will have us have this member leave the cluster. So behind the scenes, etcdadm called up to the cluster's member API, identified the local member, and then removed it from the cluster, and then cleaned up on disk artifacts. And so now, if we go to if we go and list the current members, we'll see we have 1 fewer. Okay. So that was the scaling down portion, and then for the scaling up, I'm actually going to reuse the same member. Sorry, I'm going to cheat a little bit, but I can demonstrate that there's nothing, there is no etcd. I'm not turning something off and back on. I really am scaling down and then scaling back up. So yeah, let's make sure that we have the certificates on this host again. Let me just copy over that CA cert and key, and now that that's there, again I can run the join command, and I'm back to 3 members in my cluster. Now we can pretend that I just went to a fourth machine and did this, but I happen to use the same machine. So that's how you would prepare for a planned minority failure with etcdadm. relatively straightforward. It's the same as scaling up and scaling down. Now, if you have an unplanned minority failure, it's a little bit more complicated, right? First, if you can actually reach that member that is unexpectedly not participating in the cluster, if you can reach the member, first check if the data is on disk. Typically, that data is going to be under varlib etcd. That's the case for etcdadm by default. So let's look at that. So there's all that etcd data. If it's there, if the data is on disk, then as long as the etcd process is running, the member should be able to participate. So you can check the status of the etcd service. Okay, that's running. If it's not running, maybe restart it. If it's running, the data is on disk, but it's still not participating in the cluster, check for a changed IP. Maybe the machine restarted and was assigned a different IP. If that's the case, then you can actually call up to the members API and adjust that. So that's not an operation that etcdadm supports natively, but you can use etcdctl to do that. And then if the IP hasn't changed, maybe you've run out of disk space. So you can also check that. Maybe it's something else. And in that case, there are different resources. One of them is a great talk that was given at KubeCon Seattle at the end of last year on debugging etcd. So I left a link there in the slides for that. And that's a good place to turn. Now, if the data is not on disk, or if the member is not reachable over the network, or maybe you just don't have time to investigate what's happening, and you just want to replace it. So then you can identify that failed member. By identify, I mean you should know what what the network identity of that member is, but what you'll need to know is this. What you'll need to know is this identification or member ID that's on the left-hand side here, and you can find that in the member list. And once you have that, you can remove the member using etcdctl. And of course, after that, you can add its replacement by doing an etcdadm join. So the most the most frightening and the most interesting scenario is an unplanned majority failure, and I want to demonstrate how we can recover from that by using etcdadm. So this is a case where we have lost all the members in the cluster, and we want to be able to get the cluster up and running, and we have let's say a backed up snapshot, or potentially maybe we're able to salvage the hard disk. Maybe we lost the machines, but we were able to salvage a hard disk if we didn't have a backup. And as long as we have on disk data, we can take a snapshot of that. So let's simulate this failure. So we've got this 3-member cluster, and now let me just let's see. I'm going to stop. Yeah, I'm going to stop etcd. Systemctl. So what I meant. Stop etcd. I'm going to stop the etcd service here. I'm going to stop the etcd service here and also on this host. Okay, so now we don't have any of those members up. But what we do have is the ability to take a snapshot of, let's say that either we had a backup, or maybe I was able to access the hard disk of this member. So let me go ahead and take a snapshot of the on-disk data. So etcd is not running. I can just demonstrate. etcd is not running here, but we do have the data, and so we'll take a snapshot. So take a snapshot, and then we'll save it. Sorry, I think is it looking for the API? Okay. So I'll need to just use the snapshot I took earlier. Sorry about that. So I have the snapshot that I took earlier, and I will use this to first I'll copy this over. So I'll copy over the snapshot to a different host, and I will start a brand new cluster using that snapshot there. So first of all, let me clean up. I'll do an etcdadm reset, and I'll skip cleaning up the member from the API because the cluster is gone. There's no way to call the API. So let me, okay. So I've cleaned all that up, and now I should be able to etcdadm init, and then point it to a snapshot. And what's going on behind the scenes, as you can see here, is that etcdadm is grabbing that snapshot from the disk and then seeding the new etcd cluster with it. So once this is done, now I have the previous cluster's data, but I've started a completely new etcd cluster. And now I'll need to copy over those certificates because I want to now join those other hosts to this new cluster. So first of all, let me just clean up here as well. And this is just cleaning up everything locally and not trying to call up to the etcd API to change the membership or remove the member. Okay, so now I've got everything cleaned up on those other hosts. Let me copy over the certificates. And now I should be able to just join. Okay, so now I'm joining, and I'm recovering. I'm recovering from this complete cluster outage by creating a single member and seeding it with a snapshot. So I preserve the data from the cluster that failed, and now I'm scaling it, scaling this new cluster up. Okay. Looks like maybe I did not copy over the certs, or I did not reset correctly. So let's try running a reset again, and let's see what is the status of my that's interesting. That last node was unable to connect. So let's try this again after I make sure that I have the certs copied over. Okay, so let's check that those certs are there. The certs are there, and let's try to do a join. Okay. Well, I seem to have hit an issue. So yeah, the demo gods. I don't think I'm out of space, but clearly something is wrong. The etcd service. Huh. Okay. Looks like there might be an issue in etcd itself. So I do need to take a look at that, but right now we have a 2-member cluster, but yeah, we failed to add the third. But I'll look into that. I hadn't had any issues when I was preparing. So I just want to describe what's going on behind the scenes. Yeah, the etcdadm will generate the CA and the server client certificates, and then it'll initialize the etcd data directory from the snapshot that we passed it, then write the configuration, and then create and start the systemd service. And yeah, that's how you seed the new cluster, and then scale up. That is that's what I wanted to demonstrate, and then I wanted to quickly mention sort of what's on the roadmap in 2019 for etcdadm. We're definitely considering implementing some kind of automation that invokes the etcdadm CLI, right? I think it's very important to keep those separate so that you can always have a manual recovery process that you can, for which etcdadm will be the tooling. But if you have, it sometimes makes sense if you have the right external APIs, if you have the right dependencies in place, and the ability to, rely on some external mechanism to make your automation highly available, which is the case, and often in public clouds, right? Where if there is, a problem with the underlying system that is ensuring your recovery service is highly available, someone at a different company will be paged at 3 in the morning. But nevertheless, if there's an issue that brings your this automated recovery service or automated configuration service for your cluster down, you always want to have a manual recovery process and the tooling to make that process straightforward. Also, we're thinking about implementing periodic backups. So this is also something that would integrate with potentially different network storage or potentially different public cloud APIs to make it simpler for anyone that's running an etcd cluster to have backups periodically. And then we want to improve the upgrade support. So today, upgrade is simply you specify a new version of etcdadm, and you can run etcdadm join and specify that newer version, and the join command is idempotent, and so you'll end up just installing the new version and restarting the systemd service. But it would be helpful to have an explicit upgrade command, much like kubeadm does. And yeah, finally, please, if there's some feature that you would like to see in etcdadm, file an issue on GitHub, and you can always find us on the etcdadm channel in Kubernetes Slack.
Cool. Thank you so much, Daniel. We have several questions from the audience. Let's start with Kenneth Yang, who asks, if you're using managed Kubernetes services like EKS, does etcd still need to be considered in the cluster, or does AWS completely take care of it?
If you're using a managed service, typically the control plane, including etcd, is completely taken care of for you. So no, you don't need to use etcdadm in that case.
Okay, cool. And to kind of build on that a little bit, Paul Burt of CoreOS fame asked us, which Platform 9 customers are most insistent about being HA with etcd?
Which customers are most insistent on being HA? I guess the what I'm wondering is, or not what I'm wondering, but when customers think about I think HA for etcd, they're just thinking about the potential time to recover from a control plane from an API outage. So with HA etcd, or multiple control plane replicas and then multiple etcd members, typically you can tolerate one or potentially two or three, depending on your etcd cluster size. You can tolerate failures, which can be especially important on premises, where the time to bring up a replacement is not as fast as in a cloud environment. Clearly, if you're running etcd, for example, if you're running your control plane in a Kubernetes cluster itself, and you're running etcd in a Kubernetes cluster, and there's a great way to do that, right? It's the etcd operator. It's great if you have a Kubernetes cluster already there. If you're using that, you may just opt to have a single etcd member and rely on being able to quickly reschedule the pod. But in an on-premises environment, or where you're really concerned about API downtime, that's when you start looking at the ability to tolerate failure.
Okay, cool. Well, Paul, hopefully that meets your kind of expectations. If anything, feel free to ask questions, or again, using the Q&A. Gaurav Kumar asked, please share how you fixed the issue not being able to add the third member after the majority failure.
That's the first thing I'm going to do, and yeah, that's like I said, the demo guys.
Yeah. We've all been there, man.
Yeah. But yeah, I would like to I'd like to follow up. If I find an issue, I will immediately file an issue on the etcdadm repo. I don't know if there's a good way to sort of follow up with the audience here, but yeah, if I can, I definitely would like to do that.
Yeah, I'm sure Taylor can help out. If not, Gaurav, maybe reach out on etcdadm in Kubernetes Slack, and I'm sure Daniel can provide an answer there for you. All right, if there's no etcd member connected to the cluster, then taking a snapshot is not possible. So that's more of a statement rather than a question. But I think you get to the heart of it, which is you did a snapshot. Can you explain how that occurred?
Yeah. So what I need to do is to take I think I can take the data directory directly, yeah, rather than a snapshot. But I think in that case, yeah, I would have, or I should have had one member running and then taken the snapshot and then brought that last member down.
Okay, and let's continue down that thread a little bit more. David Olemacher, hopefully I said that correctly. Can I copy the etcd data from disk directly without using etcd cuddle sh snapshot save? The use case being I had to pull the disk out of the server to access the data. Furthermore, could I put the disk in a new server and use the link so that etcd could find the data?
So taking the data directory, and you can start etcd with that same data on a different machine, but it won't be able to join a cluster unless that cluster its members list is updated to the new network identity. So if the network identity changes, you won't be able to just take that data directory and copy it over. You also need to make an etcd API call to update the peer URLs and client URLs. And if you do that and you configure etcd correctly, or rather you can just copy over the configuration and start etcd on that new machine, then that should work. That's the migration process. In fact, there's a link to that in the slides.
Awesome. And again, as a reminder, the slides will be made available in an email that'll be sent out to you post-event. Serge Dabrowski asks, is it possible to provide already generated certs from init? So
Yep. Yeah, that's a great question. So I think the question is sort of, will etcdadm support an external CA, right? Where you don't want to have the CA cert and key on each of these members. Yes, it is possible. It's not something that's been let's say it hasn't been thoroughly tested, but that would be a great feature to have. For anyone that's using etcdadm as part of like larger automation system, where you're providing the certs externally, or you're signing them externally. Something that I think etcdadm will end up doing is what kubeadm has done, and that is generate CSR, so certificate signing requests, write them to the disk, and then allow those signing requests to be signed, on a different machine somewhere externally. And that would be a nice option, because then you can delegate all of the sort of all of the details of what the certs need to look like, what they need to have in their common names and the subject alt names to etcdadm, and then you can just rely on your external CA to sign them. If you don't want to do that, you should be able to just provide the signed certs yourself, but then it will be your responsibility to ensure that all the details of the certs are correct. Of course, etcdadm can validate those certs before starting, but yeah, you'll have to make sure that you're doing it correctly. You're generating the CSRs correctly initially.
All right, cool. We got a couple more minutes and a couple more questions. Here, Superjeet Ghost asks, here etcd seems to be running natively. What if I want to run etcd in a containerized environment? Does etcdadm have capability for the same?
That's a great question. Today, etcdadm only runs etcd as a systemd service. Running systemd in a container, not really a great option, but there's really nothing stopping etcdadm from supporting running etcd in a container. The reason that today it supports systemd service is because we wanted to decouple etcd lifecycle from the lifecycle of a container runtime or Kubernetes itself. But that's definitely something that we want to support in the future.
Cool. Awesome. So a little comparison here. Cube Square asks, why should I embrace etcdadm when I have CoreOS etcd operator?
If you can use etcd operator, then you should definitely use it. Now, if you are using etcd operator and you're doing that without having a Kubernetes cluster, which itself has an etcd, please tell me how you've done that, because I would like to do the same. Yeah, etcd operator is meant to operate etcd in pods in a Kubernetes cluster, but it doesn't operate the etcd that is actually being used by that cluster. So for that cluster, you could use etcdadm, and then for anything else, if you need etcd, run it in pods on that cluster, and I think that composes quite well.
Cool. Thomas Velasek asks, can you use etcdadm on etcd clusters that were not built by etcdadm?
That's a good question. That's not something that that we've tested. I think nothing is impossible, but if if there's an option to do if it's an option to just copy over the data directory, I think that might work. You could also take a snapshot. That might work as well. Yeah, the devil is going to be in the details as far as making sure that that the configuration is correct. So it's not something that etcdadm does today. Doesn't adopt clusters, but that potentially is something that it could do in the future.
Okay, cool. And we have, we're at the top of the hour. We have time for one more question. And then again, I'd recommend everybody jump over to etcdadm and Kubernetes Slack, or go to the GitHub repo and maybe issue a question via an issue. But Marek Bartik asked, great demo, thanks. For disaster recovery, would you recommend backup / snapshot plus restore of etcd, or dumping K8's Kubernetes resources with tools like Heptio, I guess Valero? I did not know Arc had been rebranded.
That's a great question. There are, I think it depends. If you, we're recovering so that we can get our Kubernetes cluster running again. If the disaster that has hit your cluster, if it hadn't affected your control plane, that is the stateless components, if they're still running, and maybe they have the same network identity, and then your worker nodes also are still running and they have the same network identity, then all of those node records are going to be in the etcd state. And if you recover the cluster and your API servers that are still running reconnect back to the cluster, then everything will, as far as those node records, they will then the kubelets will be able to just reconnect and continue on. If you use Valero, I don't think it will preserve the identity of the cluster. It will preserve some of the configuration of your applications, and that I don't know exactly how it would compare in terms of recovery time, but certainly it's if you're able to recover etcd and the rest of your nodes are still running and still have the same network identity, I've seen recovery be relatively seamless as far as all those other nodes are concerned.
Cool. All right. Well, Daniel, thank you so much for your time and expertise today. It's greatly appreciated. To everyone in attendance, thank you for spending your afternoon if you're on the East Coast with us. And again, look out for an email with a link to the deck and the recording coming soon. Thank you, and hope to see you next time.
All right. Thanks very much.
Bye.